Welcome to our lesson on the arithmetic progression and the geometric progression. We've already looked at the basic concepts or principles that are involved in the two types of sequence, which is the arithmetic progression and the geometric progression, where we have said the AP is where you have a common difference when you subtract consecutive terms, and the GP is where you have a common ratio when you divide consecutive terms. So we'll look at some more examples and see how we work out questions involving the AP and the GP. So there's a question which says, for the sequence 25, 22, 19, 16, find an expression for the nth term and find the sum of the first 20 terms. We find the formula for the nth term and the sum of the first 20 terms. So we have a sequence which is 25 followed by 22 followed by 19 followed by 16. The sequence continues with terms that are not included. So if we analyze this sequence, we'll notice that it's an arithmetic progression, because when we subtract 16 minus 19, we'll find a negative 3. If we try it here, 19 minus 22, we'll find a negative 3. If we try it between the first two terms, we have 22 minus 25, which will give us negative 3. So there is a common difference D. So in this particular sequence, it means our first term, which we can call T1, okay, which we can call A, the first number in the sequence is 25. Then the common difference we are getting when we subtract consecutive terms is negative 3. Please take note that, for example, between the first two terms, we will not subtract this and say 25 minus 22. No. The procedure for obtaining the common difference is you start with the term on the right and then take out the term on the left from the term on the right. So it is 22 minus 25, or 19 minus 22, or 16 minus 19, in that order. You start with the term on the right, subtracting the term on the left from the term on the right. So we want to find an expression for the nth term. Now we know that for an arithmetic progression, the nth term, or nth term as it may be written, is given as the first term plus n minus 1d. That is the formula for calculating the nth term. So in this formula, what we need to substitute is a and d, because these two variables are known. So we are going to substitute and say a is 25 plus n minus 1, d is negative 3. So we expand and simplify this expression, which gives us 25. Then when we multiply to remove the brackets here, we have negative 3 times n by expanding or distributive law. The negative 3 will multiply both the n and the negative 1. So when we multiply negative 3 times n, it will change the sign here from positive n to negative 3n. Then negative 3 times negative 1, it will give us positive 3. So we can group the like terms. We have the numbers 25 and 3, which can add on the one side to give us 25 plus 3 is 28, then minus 3n. So this is the formula for the nth term, or Tn, the nth term. The formula for the nth term will be given as 28 minus 3n. Then we can find the sum of the first 20 terms, the sum of the first 20 terms of this sequence. The formula for finding the sum of a given number of terms is Sn n over 2 2a plus n minus 1d that is the formula. So we are finding the sum of the first 20 terms, meaning S of 20. So we'll have, where there is n, we'll have 20 over 2. We multiply 2a. Our a in this sequence is 25. Then plus our n is 20 minus 1. Our d, common difference, is negative 3. So that is our calculation for the sum of the first 20 terms. So 20 over 2 here is 10. Then inside here we have 2 times 25, which is 50. Then we have here, we can say plus 20 minus 1, which is 19. 19 times negative 3. Okay, so we have to simplify what is inside the brackets first, where we have 50 the positive 19 times positive 19 times negative 3 will give us negative 57. Which means inside the brackets we have 50 minus 57 is minus 7, so that our final answer is 10 times negative 7, which is negative 70. That will be the sum of the first 20 terms in that progression. We can look at another example, which says, what is the position of 999 in the sequence represented by the nth term cubic n minus 1? Now, in this question, we have not been told whether it's an arithmetic progression or a geometric progression, and since we do not have the terms of the sequence listed, except one particular term which is appearing. The term is 999, and we have an expression for the nth term, which is n to the power 3 minus 1, n to the power 3 minus 1. That is the expression or the formula for the nth term, and we want to understand what is the position of this. What is the position of this particular term? Now, we know that in any particular sequence, whether it is the arithmetic progression or the geometric progression, the position of the term is represented by the variable n. So, in short, we are solving this equation for n to understand the position of the number 999. So what we need to do is to equate and solve for n. Cubic n minus 1 is equal to 999, so that we understand what the value of n is. What will be the value of n? So here, since it's an equation, we'll simply say cubic n is equal to 999 plus 1. We'll move the 1 to the right hand side. We'll transfer the negative 1 to the right hand side, so it becomes plus 1, which means cubic n is equal to 999 plus 1 will give us 1000. So to get cubic n, we introduce the cube root on both sides, cube root of n, because we want to cancel the cube. So we'll have the cube root and the cube will cancel on the left, meaning we'll remain with n, and then on the right hand side, cube root of 1000 is 10. The number that multiplies by itself 3 times to give us 1000 is 10, which means the position of the number 999 in the sequence, which is represented by the formula cubic n minus 1, this number 999 will appear in the 10th position of that sequence. We can look at another example which says, given that the 11th term of an arithmetic progression is 43 and that the first term is 3, find the common difference and then find the 4th term. So for this particular sequence, we are told that the first term, which means a, the first term is 3. The first term is 3. And the 11th term, which we know is represented by a plus 11 minus 1 d. Okay, this 11th term is 43. this 11th term is 43. So in short, we have A plus 10D. This is the formula for the 11th term, A plus 10D. So this A plus 10D is equal to 43 according to the information we have been given. And since our A is 3, the first term is 3, it means the equation will be 43 is equal to first term 3 plus 10D, and then so we are solving for the common difference D. So we group the like terms together so that we have 43 minus 3 is equal to 10D, which leads to 40 is equal to 10D. So to get our D, we divide both sides by the coefficient 10, meaning the common difference is 40 divided by 10, which is 4. So the common difference is 4. And finally, the last part of the question says we find the fourth term. So we know the formula for T4. The formula for T4, the fourth term, is A plus 4 minus 1 D. So we already have the first term and the common difference. So the first term A is 3 plus here 4 minus 1 is 3. The common difference is 4. So this will give us 3 plus 12, which is equal to 15. So that will be the fourth term.